Welcome to your Introduction to Statistics, Unit 3, Lesson 3. We're talking about probability, and today we're going to employ counting techniques. And the counting techniques we're going to look at, which I know sounds weird because you're like, okay, there's 1, 2, 3, 4. What else is there to counting? Well, sometimes counting gets more complicated. And so we're going to learn how to use a tree diagram, and then the multiplication rule of counting, and then we're going to learn about permutations and combinations. A tree diagram is a visual display of the total number of outcomes of an experiment consisting of a series of events. So if you've got one thing happening, then the next, and then the next, a tree diagram can be very helpful. So, for example, you're planning to take Psychology, Anatomy, and Physiology in Spanish 2. There are 2 sections of Psychology, 2 sections of Anatomy and Physiology, and 3 sections of Spanish 2. Use a tree diagram to determine the total number of possible schedules you could have. Okay, so here you are, and you're starting. The first thing that you have to do is select a psychology section. There's 2 of those. All right, now if you select section 1 of psychology, you still have 2 sections of anatomy and physiology available to you, so you would select one of the 2. If you had selected the second section of psychology, you would still have the 2 sections of anatomy and physiology that you could select. And then you have to make your third choice when you're going to take Spanish 2, which section you're going to be in. So no matter which path you've gone down, you're going to have 3 choices for your Spanish 2 section. And so if you want to know how many total possibilities you have, you just count how many end branches you have. So you have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 end branches, so there's 12 possible schedules for you to have. All right, so we're going to find the number of paths without constructing the tree diagram. How about the experiment of rolling 2 dice, one after the other, and observing any of the 6 possible outcomes each time? One thing that you can do is to find the number of paths is you can simply do, there's 6 possible outcomes for the first one times 6 possible outcomes for the second one, and that's going to give you 36. Would that have worked before? Let's look. What if we just did, okay, there's 2 sections of psychology times 2 sections of anatomy and physiology, so 2 times 2 is 4, times 3 sections of Spanish, so 2 times 2 times 3 is 12. So that would have told us the number of possible schedules as well. And we call this the multiplication rule of counting. For any series of events, if there are N1 possible outcomes for event E1 and N2 possible outcomes for event E2 and so on, then there are N1 times N2 times all the way to NM possible outcomes for the series of events E1 through EM. Let's look at an area code example. In the past, an area code consisted of 3 digits, the first of which could be any digit from 2 to 9. The second digit could be only a 0 or 1. The last could be any digit. How many different such area codes were possible? Okay, well, if you count how many choices you have for the first digit, let's see, it could be a 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 8 different values. So you would have 8 times. The second digit would just be a 0 or 1. So there's only 2 choices there. And then the last could be any digit. So 1 through 9 and 0. There's 10 of those. And so if you multiply them all together, you get 160. Ordered arrangements. And how many different ways could 4 items be arranged in order from first to last? Well, your first spot could be taken up by any of the 4 objects. And then times, once you've selected an object to go in the first spot, the next one you'd only have 3 possible objects. And then for the next one you'd only have 2 possible objects. And then the last one there'd be no choice to make, you'd have 1 object left. So the total number of ways you can order 4 objects from first to last, multiply all those together, you get 24. Okay, we need to introduce some notation called factorial notation. N with an exclamation mark is an N. Okay, it's N factorial. N factorial is applied only when n is a whole number. N factorial is a product of n with each positive counting number less than n. So, for instance, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is 120. 3 factorial is 3 times 2 times 1, which is 6. There's a couple of things that we have to take by definition. 1 factorial is 1 and 0 factorial is 1. All right, so we're going to complete the factorials. 4 factorial would be 4 times 3 times 2 times 1. It's 24. 10 factorial is 3,628,800. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 is 720. 15 factorial is 15 times 14 all the way down to times 4 times 3 times 2 times 1, and it is 1.3077 times 10 to the 12th power. Huge number. Okay, we're going to talk about permutations and combinations. A permutation is an arrangement in a particular order of a group of items. There are to be no repetition of items within a permutation. In fact, you don't even want to think about permutations or combinations unless there's no repetition. So permutation. For permutation, order matters. Okay, and what I always tell people is if something started happening to you and you started mutating, you turned green, all of a sudden you grew 3 extra arms, you developed wings. All right, if you went in and were examined by doctors, they would want to know the order that things happened per mutation. Okay, the turning green, the sprouting extra arms, the sprouting wings, they want to know what order it happened in. So permutations are involved in ordered events. So listing permutations. How many different permutations of the letters A, B, and C are possible? Well, there's 6. Let's look at them. Okay, it would be A, B, C, and then we'd change the order there of the B and the C. So you'd have A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. Those are all the different permutations. How many different 2-letter permutations of the letters A, B, C, D are possible? Well, there's actually 12. Okay, so you're going to take them 2 at a time, and order is going to matter. So if you look on here, AB is on here, and so is BA. AC is on here, so is CA. AD is on here, so is DA. Okay, then let's look at some that are left. We haven't done B and C yet, so B and C, B and D. And then let's change the order, CB, DB, and then let's see, the only 2 that are left are CD, DC. Okay, so there is a formula for this. The number of ways to arrange in order n distinct objects, taking them R at a time, is P n R, which is equal to n factorial divided by n minus R factorial, where n and R are whole numbers and n is greater than or equal to R. Another way to note that is NPR. You'll see both ways. So the number of permutations of 7 objects taken 3 at a time, P7, 3, is equal to 7 factorial over 7 minus 3 factorial. So that's 7 factorial over 4 factorial. It's going to give you 5,040 over 24, which is 210. Okay. A teacher has chosen 8 possible questions for an upcoming quiz. And how many different ways can 5 of those questions be chosen and arranged in order from number 1 to number 5? So order matters. And so we're going to do the number, we're going to find the number of permutations when you have 8 objects and you're going to choose 5. So that's going to be 8 factorial over 8 minus 5 factorial. So 8 minus 5 is 3. So 8 factorial over 3 factorial. Okay. And so that's going to equal 8 times 7 times 6 times 5 times 4. Because the 3 times 2 times 1 that you have on top is going to cancel with the 3 times 2 times 1 on the bottom. And so you get 6,720. Okay, so permutation order matters. Combination is a grouping in no particular order of items. It's kind of like a combo meal. If you go to Chick-fil-A and you order a number 1 combo with a Coke, All you care is that your Chick-fil-A sandwich is in there, your waffle fries are in there, and that you get your Coke, okay? You don't really care whether they hand you the Coke first, and then, you know, they put the waffle fries in the bag next, and then the sandwich, or if they put the sandwich in the bag, and then the waffle fries, and then hand you the Coke. Doesn't matter what order. You just want everything to be there. Okay, so the combination formula is going to be where you have n objects and you're going to take r at a time. It's going to be similar to the permutation formula. You're going to have n factorial over n minus r factorial, but then you're also going to have r factorial in the denominator. What that does is it divides out all the different orderings. Okay, so again, n and r are whole numbers, and other ways to write this are NCR, or you can use like a big set of parentheses with n on top and r on the bottom, and a lot of times this is n choose r is how that's said. So the number of combinations where you have 9 objects and you're going to take 3 at a time. Again, order doesn't matter, so you're going to have 9 factorial over n minus r factorial. This one's written just a little differently. N minus r, 9 minus 3 factorial times r factorial, so 3 factorial. So you have 9 factorial over 3 factorial times 6 factorial, and that's going to give you 84. Okay, a teacher has chosen 8 possible questions for an upcoming quiz, and how many different ways can 5 of these questions be chosen if order makes no difference? She doesn't care about what the order is, it's just choosing the questions. So this is just how many combinations are there when you have 8 objects and you're going to choose 5 of them. So that's going to be 8 factorial over 5 factorial times 3 factorial, and that's going to be 56. Okay, determining the number of outcomes of an experiment. If the experiment consists of a series of stages with various outcomes, use the multiplication rule or a tree diagram. If the outcomes consist of ordered subgroups of R outcomes taken from N outcomes, use the permutation rule when order matters. And if order doesn't matter, then do combination rule. Okay, guys, that's it for Unit 3, Lesson 3. Go ahead and do the problems to try on your own. Thank you again for watching the video and taking good notes. I will see you in class. I hope you have a terrific day.